So briefly, the reason that we used t was because it was unknown sample. We don't know the standard deviation, we don't know the population mean. And so in review, we look at this, right? Those are the two differences. We would use z if we knew this standard deviation of the population. Would be the difference there. And then we had, just to review, and on the quiz there, we had 3 different functions that we could use on our calculator. Most of the time we use t-CDF because it finds the cumulative probability, or inverse t because it takes the probability and goes backwards. We don't use the PDF as often. And we can still use one statistic to compare 2 means if they're matched together. So anytime you have like an example where there's 20 students, but each student has 2 scores associated with them, like a pre-test and a post-test. Because each score is matched together in pairs, you can either add them or subtract them, find their sum or their difference, and view that new statistic as one variable. And that's kind of what we did in this, like the loss of sweetness. We had the first minus the second, which gave us the loss. And then we also talked about the piano example, where we had their score before and their score afterwards. And we treat it as a single sample. So turn over to the back. We'll talk about 2 things. Many times the data that we're looking at it's not going to be perfectly normal. It's going to be skewed. It's going to have outliers. It might have gaps, clusters. It might have 2 peaks, etc., etc. So we have this idea that once in a while we have to be able to tell when can we use the test and when can we not use this test. When does the data fit? When does it not? So this is going to be a term we'll define for, I better type it out, it'll be easier to read. We'll define for both confidence intervals and significance tests. So we're going to say here, if I can get this, that confidence intervals or tests of significance are robust, so that's our keyword, if the interval itself or the p-value doesn't change much when the assumptions are violated. Meaning, what if we assume it's normal and it's not really normal? Does this test still work? Okay.